Okay, question number 3. Suppose the length of pin bolts X used to secure large plates to bridge sections are normally sort of a mean of 450, standard deviation of 8. One pin bolt is selected at random, not a sample, it's just one pin bolt. Find correct to the nearest millimetre, a 95% confidence interval for its limit. Well, it's going to be X plus or minus 95, 1.96 times the standard deviation, which will be 450 plus or minus 1.96 times 8, which on a calculator gives you 434.32, 465.68, and we're going to the nearest millimetre, so 434 to 466. A random sample of 30 bolts are taken. Find the lengths of the sample that have a mean, let the length of the sample have a mean, and find correct one decimal place a 99% confidence interval. 450 plus or minus 99%, so 2.58 times 8 over the square root of 30, and jumping on a calculator, that gives you 446.23 through to 453.768, which gives you to one decimal place 446.2 to 453.8. I suggest you write out all of the decimal places and then round once. Give yourself a chance to get the marks. A different random sample of 25 is taken. Find the length of the sample, have a mean of y dash. Find correct with the chance that the mean length of the pin bolts in the sample will be less than 446. Okay, so n equals 25. The probability that y dash is less than 446 is what the question's asking. And if I turn that into z, that would be 446 minus the mean, which is the same mean because it's taken from the same group. So that's 450 over the standard deviation of 8 divided by the square root of 25. And on a calculator, that gives me z being less than -5 on 2. And then if I do a normal CDF going from -infinity to -5 on 2, 1, 0, gives me 0.006 20966, or to 3 decimal places, 0.006 is going to be my answer. Okay, so that's the first parts. Part D, pin bolts continue to be manufactured by the original machine over a long period of time. A claim from the outside are now undersized. And in order to test this claim, 20 pin bolts have been from the machine, have their lengths measured. These pin bolts are found to have been measured at that. Assume the standard deviation remains like that. But we have a sample now of 20. Okay, state that a hypothesis. Well, HO is that the mean is still 450. H1 says that they're undersized, so the mean should be less than 450. To justify, I need to find the p-score. So I want the probability that x bar is less than whatever we got, 447. Given that the mean is actually 450, standard deviation is 8 divided by the square root of 20 in this particular case. So I'm going to do a normal CDF. I want -infinity to 447, given that the standard deviation is 8 on root 20 and my mean is 450. And that will give me a p-score. What that will do is it will say my mean is 450, I want 447, I want the probability of being less than 447, given that the standard deviation is 8 divided by root 20, because for a sample, the standard deviation is sigma divided by root n. On the calculator, that gave me a score of 0.046766. And since 0.046766 is less than 0.05, it is significant to a 5% level, and at a 5% level of significance, we reject HO and accept H1, which says that the mean is less than 450. And looking at part E, the original machine can also produce pin bolts with a length increase of 20%. So the new length will be 1.2 times the old length, which was P. Find the chance of a packet of 10. Okay, so the expected value of N will be 1.2 times the expected value of P, and the variation of N will be 1.2 squared times the variation of P, which will be 1.44 times 64. Since the standard deviation of P was 8, the variation will be 64. So 1.44 times 64 equals that, and I want the square root of that. Which gives me 48 on 5. And what do I like to do? I've got 10 bolts, and I want to know, where can I go? Over there, 10 bolts, and I want to know, so I've got a binomial because this is 10. I'd like to find the probability of being longer than, so probability that the new bolts are longer than 550 will be a normal CDF 550 to infinity, 48 on 5, and the mean is 1.2 times 450. $540. So I'm doing interactive, distribution, continuous, CDF. Lower is 550 because I want more than 550. Upper will be infinity. Standard deviation is 48 on 5. And the mean is 540. And that gives me that value. So that's going to equal 0.1487 383. Okay, so now it becomes a binomial because I've got 10 pin bolts and I want the probability that 2 are longer. So X is now binomial where I have 10. The probability of being longer is 0.148783, and I want the probability that X equals 2, which will be a binomial PDF. It's just equal to 2, isn't it? Exactly 2. 2, 10, 0.1487. So I might copy that before I jump in. Copy, interactive, distribution, discrete, binomial PDF. I want 2 of them. I had 10, and the probability of success is paste, gives me that answer, which is 0.27, 0.27456, and I want how many decimal places? 3, I thought it was. Find to 3 decimal places. So my answer is going to be 0.275 to 2 decimal places. And that's that whole question.